Today we discuss on important topics related to inner product space. We also start from two matrices are congruent. Okay, we write the definition here. Let A and B belongs to Mn cross Nf, then B is said to be congruent to A if there exists an invertible matrix Q belongs to Mn cross Nf. That means the n cross n matrices where entries from this field F such that V equal to Q transpose AQ. Understood? Then we're also going to further discussion one theorem. Okay, we write this theorem here. Let V be a finite dimensional. V be a finite dimensional. Okay, vector space with order basis. Vector space with order basis. Vector space with order basis beta equal to v1 v2 dot vn. Okay, and gamma equal to here w1 w2 dot wn. Understood? And let q be the change of coordinate. Q be the change of coordinate matrix. Change of coordinate matrix. Okay, change of coordinate matrix, changing gamma coordinates into beta coordinates. Changing gamma coordinates, okay, into beta coordinates. Okay, then what happened? Then for any age belongs to BV. Understood? Any age belongs to BV. We have what? We have psi gamma h equal to q transpose psi beta h q. Okay, and therefore here psi gamma h is congruent to psi beta h. Okay, therefore psi gamma h is congruent to psi beta h. Okay, understood? That means this one is the theorem. Let V be a finite dimensional vector space. V be a finite dimensional vector space with order basis beta and gamma, and Q be the change of coordinate matrix, changing gamma coordinates into beta coordinates. Okay, then for any h belongs to PV, we have gamma psi gamma h equal to q transpose psi beta h q. Therefore, psi gamma h is congruent to psi beta h. Understood? Now we're going to proof of that. We erase that portion and going to proof of that. Okay. Here we write proof. Okay. There are essentially proof of this theorem. Okay. Now we discuss here. Suppose that what a equal to psi beta h. Okay, and b equal to psi gamma h. Understood? Then what happens? Then for I1 less than equal to ij less than equal to n. Okay, what happened? Here wi equal to here k equal to 1 to n, qki here vi. Okay, sorry, qki vk. Okay, k equal to 1 to n, and wj equal to here r equal to 1 to n, qr here qrj vr. Understood? Then what happened? This one is r equal to, okay. Then what happened is here we write it thus beta bij equal to what? H of wijwj equal to what? Equal to h of summation here k equal to 1 to n qki vk here, and then wj is remaining, okay. Then what happened is here we write it this one equal to summation k equal to 1 to n. Understood? qk here h of vk wj. Understood? Then this one equal to what? Again we write in this way here k equal to 1 to n qk here h vk, and wj equal to what? R equal to 1 to n, okay. R equal to 1 to n q r j vr. Then this one equal to what? This one equal to k equal to 1 to n r equal to 1 to n here q k I here q k I, and then here q r j, okay. q k I and q r j, okay, and h of vk vr. Understood? Then this one equal to what? This one equal to here k equal to 1 to n, okay, qki, and r equal to 1 to n qrj, and this one equal to akr, okay. Then what happen is here, then we also erase our portion and going to further discussion of that. Okay, here we write in this way, this one equal to k equal to 1 to n, okay, qki, and r equal to 1 to n here akr and qrj. Understood? Then this one equal to what? This one equal to k equal to 1 to n qki, and this one equal to aq here kj, okay, aq kj. Then this one equal to here k equal to 1 to n qik transpose aq here kj. Understood? Then this one equal to q transpose aq here ij, okay. Then what we get? We get this one bij equal to q transpose aq ij, okay. Then what happened? Then we also see that, okay, hence b equal to q transpose aq, okay. Understood? Not a problem at all. I think all are understood this one, okay. Too easily I think all are understood this one, okay. Then we also discuss here some corollary related to that. We write it now. Corollary. Let V be an n-dimensional vector space. Let V be an n-dimensional vector space. Okay, with order basis, with order basis. Okay, beta, and let H be a bilinear from on V. H be a bilinear from on V. Okay. Then for any n cross n matrix B. Okay. If B is congruent to if B is congruent to if B is congruent to psi beta H. Okay. Then there exists an order basis. Then what happened? We erase that portion and going to further discussion in above. Then what happened? Then there exists an order basis. There exists an order basis. Okay. Then there exists an order basis gamma for V. Okay. Such that psi gamma H equal to B. Okay. And furthermore, okay, if B equal to Q transpose psi beta HQ, okay, for some invertible matrices Q, for some invertible matrix Q, okay, then Q change, changes gamma coordinates into beta coordinates. Gamma coordinates into beta coordinates. Understood? Okay. Then Q changes gamma coordinates into beta coordinates. Okay, not a problem at all. So we now write here proof. Let V be an n-dimensional vector space with order basis beta and let H be a bilinear from on V. Then for any n cross n matrix beta B is congruent to gamma beta H, then there exists an order basis gamma for V. Here psi gamma H equal to beta B. Then furthermore, if B equal to Q transpose psi beta HQ for some invertible matrices Q, then Q changes gamma coordinates into beta coordinates. Understood? Now we're also going to prove of that. We erase that portion and going to prove of that. Here we write proof. Okay. Suppose that what B equal to Q transpose psi beta is Q. Okay. For some invertible matrix Q, for some invertible matrix Q. Okay, then what happen is here, and beta equal to v1 dot vn. Understood? And let gamma equal to w1 w2 dot here wn. Okay, then where wj equal to I equal to 1 to n q, here ijvi. Okay, for 1 less than equal to j less than equal to n. Okay, then what happened is here, since q is invertible, okay, then what happened, then gamma is an order basis for v, gamma is an order basis for v. Okay, and q is the change of coordinate matrix, and q is the change of coordinate matrix. Okay, that changes gamma coordinates into beta coordinates, that changes gamma coordinates into beta coordinates. Okay, then what happened, therefore b equal to here q transpose psi beta h q equal to psi gamma h. Understood? Not a problem at all. Okay, here b equal to q transpose psi beta h q, then obviously this one equal to psi gamma h. Okay, then we also now erase that portion. What we discuss this one, just congruent, how ba congruent, and obviously psi gamma h and psi beta h are congruent. Okay, when we also change, q is the change of coordinate matrix from gamma coordinates into beta coordinates. Okay, then we also now discuss in this way. Okay, we erase that portion. That means if b is coordinate, what b is congruent to the psi beta h, and here d is also, that means congruent to psi gamma h. Okay, now we also discuss in this way, if b is congruent, that means b equal to q transpose aq. Okay, then this b equal to what, here phi gamma of beta. Okay, or we write it this one equal to, that means what, psi gamma of h. Understood? And this one q transpose, here this one psi beta of h. Okay, that means psi beta h and psi gamma h, and represent this one is b and this one a. Understood? Okay, yeah. So I think that means two matrices, how this one are congruent, and how we also, if we change this coordinate matrix, and obviously changing the basis gamma coordinates into beta coordinates, then obviously that means we get two congruent matrices. Okay, two congruent matrices related to that. Understood? So today I stop here. If you get this type of video, please subscribe my channel. If you have any questions, comments, suggestions, write it in comment box. And if you want to give like, please click on like options. Okay, so today I stop here. Thank you.